Welcome. In this 1-hour tour, I'll map South Africa's UAV ecosystem end to end and show where engineers plug in. Here's the route map. We'll start with definitions, then a short story, then we'll unpack South Africa's regulatory framework, glance at key technologies, visit the big application sectors, look at market size and leading enterprises, and close the skills, risks, and a forward view to 2035. We'll stay inside three rings: core platforms and regulations, that includes airframes, propulsion, flight control, test ranges, and SCA licensing. Specialized services, including operators, training, BVLOS compliance, local research and development. And then finally, application verticals: anti-poaching, inspection, precision agriculture, cinematography, and last mile trials. An unmanned aerial vehicle, or UAV, is an aircraft with no pilot on board, flown remotely or autonomously. Drone is just a common shorthand. The word drone traces back to the male honeybee named Dran. In the 1930s, the British Queen Bee target aircraft had a distinct buzzing sound that popularized the term for pilotless planes. The UAV industry in South Africa has evolved into a dynamic and multifaceted sector, combining world-class technological innovations with strategic applications across both civil and defense domains. As of 2024, South Africa's UAV market is valued at over $500 million, with projections of surpassing $1.2 billion by 2030. Home to a diverse ecosystem of drone manufacturers such as Alti, Denel Dynamics, and Melco, the country also hosts leading subsystem providers like S-Plane Automation and Rautec. Applications span precision agriculture, mining, infrastructure, inspection, security, and emergency services. While the industry benefits from duty-free imports on most components and a supportive government initiative under the fourth industrial revolution, it still faces regulatory and funding hurdles. Nevertheless, South Africa remains a regional leader, positioning itself as a hub for UAV innovation services and exports across the African continent. South Africa's UAV sector is set for rapid growth, fueled by advanced technologies like hydrogen propulsion, swarm systems, and AR analytics, alongside regulatory reforms enabling BVLOS operations. Backed by initiatives such as the Drone Council and Aerospace SEZs, the country is strengthening its manufacturing and exports, cementing its role as Africa's UAV innovation hub. Four form factors dominate the skies: fixed wing, a long-range endurance-based platform that often needs manual launch and landing solutions. Fixed wing hybrid VTOL has vertical takeoff, efficient wing-borne cruise, and is ideal for mapping and patrols. Single rotor or helicopter, efficient with heavier payloads but more mechanically complex. And then multicopter, the workhorse for inspections, media, and security. Agile hovering but with shorter endurance. In the mid-1970s, the Council for Scientific and Industrial Research, CSIR, in Pretoria began work with Kentron on a small lightweight surveillance UAV called the Champion, which first flew in 1977. Four were built, a pre-production model and three production models numbering 101 to 103, and some or all were deployed to what was then Rhodesia back in 1987 for operational trials, while providing surveillance assistance in this country's civil war. This set an early lab-to-field loop that set the tone for local innovation. South Africa's UAV timeline starts with CSIR and Kentron's Champion prototype in 1977, a laboratory-to-field leap that set the engineering tone for decades. Through the 1980s, the SAF fielded IAI Scout systems operationally, establishing doctrine and cruise. In 1987, the locally built Seeker-1 entered service and saw real-time combat use, anchoring an indigenous capability. In 1990, Seeker-2 brought upgrades and experimental stealth work like Seraph, while ATE's Vulture introduced zero runway, catapult launch and net recovery tactics suited to bush operations. In 2004, Denel unveiled the Battalier concept for long-range maritime surveillance. Civilian crossover accelerated next in 2012 as Seeker-2 supported anti-poaching in the Kruger National Park, and by 2014, Desert Wolf's Skunk octocopter pioneered non-lethal crowd control payloads. Regulations caught up in 2015 when Part 101 made South Africa the first African state with a comprehensive drone rule set, catalyzing a commercial boom. Hybrid veto leadership followed as Alti popularized transition platforms in 2016-2018. The country's export credentials strengthened with Seeker 400 deliveries in 2021, and Africa's largest indigenous MALE, the Milkor 380, achieved its first maiden flight in 2023. Here's the map for the rules of the road. South Africa's drone regime sits on the Civil Aviation Act, with Part 101 and CATS 101 as the day-to-day rulebook. Commercial flying pairs people approvals with organizational approvals and basic airworthiness. South Africa's drone rules rest on three layers. The Civil Aviation Act of 2009 sets the legal foundation. The Civil Aviation Regulation, notably Part 101, spells out how RPAs are operated, and CATS 101 provides the technical standards that make those rules enforceable. In practice, Part 101 is the everyday rulebook shaping who may fly, what must be approved, and how the risk is contained in commercial missions. It's also worth remembering that South Africa led Africa by publishing a comprehensive drone rule set under Part 101 back in 2015, which is why so much of the industry language you'll hear maps back to this structure. If you're flying for business, you stand on three pillars. First, the Remote Pilot License, RPL. You must be at least 18 years old, hold a Class 3 medical, pass theory, and demonstrate competence in a flight test. Second, the Remote Operator Certificate, or ROC, at company level, which formalizes your SMS, operations manual, and named post holders. Third, Operations Specifications, or OPS specs, the exact privileges that you are authorized for, such as night operations, E-VLOS, B-VLOS, or dropping articles. Alongside this sits airworthiness. Commercial drones are registered, carry ID plates, and are kept airworthy under a documented maintenance program. Many operators also field transponders, altimeters, and lights appropriate for the mission profile. Every operation starts by declaring why you are flying. Private or recreational flights are strictly personal, no commercial outcome, typically under 7 kilograms and confined to restricted VLOS. Commercial flights are for hire or for business use. Corporate flights serve internal company needs, and non-profit covers humanitarian or research work. Flight rules scale by risk. RVLOS keeps you within 500 meters and below nearby obstacles. VLOS means you or an observer can always see the aircraft unaided. E-VLOS extends range with trained observers and an agreed-on communication plan. And B-VLOS takes you beyond visual line of contact, only with specific authorization and robust mitigation. B-VLOS demonstrates detect and avoid, reliable C2 links, and fail-safe profiles backed by procedures and training. Baseline commercial limits remain less than 120 meters above ground level, daylight only, and standoff from people, roads, and buildings, with a 10-kilometer buffer from aerodomes, unless coordinated and approved. Integration is happening step by step through controlled trials and corridors. South Africa has enabled B-VLOS experimental corridors, such as the Western Cape's Drone Corridor and the Krugersdorp test range, while prototype use-based trials explore live tracking, dynamic geofences, and remote authorization. But B-VLOS remains permission-based. Operators submit CONOPS with mitigations like DAA, long-range C2, and structured risk assessment. A notable case was United Drone Holdings, securing South Africa's first B-VLOS waiver by fitting iris automation onboard detect and avoid to autonomously avoid conflicts. Safety lives in routines. It is recommended to run pre-flight risk assessments such as SORA Light, so hazards and mitigations are explicit. Follow battery safety and lithium-ion fire protocols. Satisfy detect and avoid expectations as mass and mission risk increases. Keep clean maintenance schedules and logbooks for both aircraft and pilot. Currently, Regulators and industry are converging on geofences as default safety net and remote ID as the digital license plate, alongside a national UTM position to enable routine BVLOS through live tracking and conflict alerts. Non-compliance has real teeth. Authorities can impose fines of up to 50,000 Rand and in severe cases imprisonment, with the SEAA ramping up inspections and SAP's RPAS team backing enforcement. At the same time, South Africa aligns its approach with international risk-based models such as ICAO, Jaru Sora, and parallels to the FAA. As the system shifts, it will streamline approvals for well-mitigated missions, while clamping down on risky behavior. Much of what powers modern drones was borrowed and then refined for aviation duty cycles. High-torque brushless outrunner motors from the RC world, paired with fast electronic speed controllers, give multicopters the precise low-latency thrust changes they need to hover, hold position, and lift meaningful payloads. Lightweight lithium polymer packs from consumer electronics devices deliver excellent energy-to-mass ratios. Phone-grade MEM-IMUs feed flight controllers the data that stabilize the airframe, while multi-constellation GNSS provides waypoint navigation and return-to-home accuracy. Composites from aerospace and sport keep structures stiff and light, and gimbaled CMOS cameras turn airframes into mapping and inspection media tools. Finally, robust 2.4 and 5.8 GHz radio links use frequency hopping and smart antennas to close down the loop between pilot, payload, and aircraft. Under the hood, modern UAVs center on a flight control stack like Pixhawk, Cube Class, or S-Plane Autopilot running AudioPilot or PX4, coupled to a mission computer that handles autonomy, geofencing, terrain following, and failsafes. Airframes are mapped to missions: multi-rotors for precise hover, fixed wing for efficient cruise, and a hybrid VTOL for the middle ground. Payloads give purpose. Sony A-series mapping cameras, Cube 240 LiDAR for true ground models, and stabilized infrared gimbals for inspection and security. For integration and safety, we layer parachute recovery and detect and avoid like Iris Automation, KCR. The next leap hinges on industrializing what works in demos. BVLOS at scale requires certified detect and avoid systems, resilient long-range C2 with spectrum discipline, and integrations with geofencing, remote ID, and more secure communications like Express LRS and Crossfire, and evolving UTM services. Onboard autonomy and AI analytics should turn raw imagery and LiDAR into actionable maps, crop indices, defect detection, and secure alerts without heavy processing. Maturing homegrown sensors, avionics, and mission computers will reduce import bottlenecks and harden the supply chain. The South African drone market clusters into 5 practical arenas: agriculture for crop health, spraying, and yield forecasting; mining and extractors for stockpiles, pit models, and hazardous area inspections; security and public safety for patrols, incident responses, and anti-poaching; recreational for events and cinematography; and finally military for ISR and technology trials. South African agriculture is primed for drones because large, varied farms need fast, repeatable field-level analysis that don't trample crops. The market is already active at around 60,000 hectares a month that are flown for mapping, crop health, and spraying. With agricultural drones, revenue projected is to rise from 55 million in 2024 to 184 million by 2030. As producers chase water, fuel, and chemical savings alongside yield gains. On pricing, orchards typically pay 45 to 85 Rand per hectare for multispectral mapping and 150 to 250 Rand per hectare for spraying, with returns on investment of 5 to 10% yield gain and a 15% chemical saving. Note that spraying counts as part 137 of aerial work, so licenses is needed per operator and aircraft. With 80% of commercial farmers having less than 100 acres, many producers prefer contractors rather than buying a 350,000 Rand spraying drone outright. Step 1 is situational awareness. A short, low-altitude RGB mission delivers centimeter orthomosaics to check roads, fences, wind damage, and pest hotspots. Add multispectral, and you compute individuals like NDVI to spot stresses before it's visible. Local leaders show how this scales. Aerobotics dominate fruit and nut analytics with drone scan and yield forecasting, while RocketMine flies VTOLs with Cube 240 LiDAR to build canopies and elevation models for sugar, timber, and large estates. The workflow stays simple. Plan the grid, fly, stitch, then annotate actions so farm teams can act within 72 hours. Orchids are a South African strength, and Pertree analytics are where drones shine. Imagery separates canopy from shadows so you can count trees, size of canopies, and classify health. Then fuse with ground data and pack out history for block level yield forecasts weeks earlier than manual sampling. The payoff is better labor planning, smarter picking windows, and fewer surprises at the packhouse, while multispectral, thermal missions, LiDAR modeling, and vineyards block zoning round out to robust scouting toolkits already common in Western Cape estates. Sprayer drones make targeted interventions practical. They reach awkward blocks, operate where tractors would bog after rain, and keep people away from chemicals. This is not without its own challenges. You need to nail droplet size, ground speed, swath spacing, and buffers. In South Africa, this counts as dropping articles, so OpSpecs must cover it. Pilots hold RPLs, and drift mitigation is documented. Paired with variable rate prescriptions, teams treat only stressed zones to curb inputs without hurting yields. Water is gold. Thermal and multispectral flights flag over and under irrigation, blocked emitters and leaky valves on pivots. While in orchards, you rank blocks by stress, so irrigation matches actual demand and not averages. The SCAA issued the first spraying ROC in 2020 for a DJI Agras MG1P via DC Geomatics, and many operators now integrate aerobotics to scout driven prescriptions for variable rate actions. A 20-minute flight can save a week's worth of guessing and an entire season's yield. Beyond crops, long-endurance VTOLs such as Alti Transition or Denel Seeker 2 with thermal payloads support night patrols on game farms, while mixed crop livestock operations use small multi-rotors to locate stray cattle and check fence lines without the 30-kilometer bucky run. Good agricultural operations stay quietly compliant. Fly VLOS or e-VLOS with agreed buffers near homesteads and public roads. The value chain is already specialized. Hardware OEMs sell or lease airframes and payloads. Data and analytics firms price per hectare or per tree with APIs to insurers and exporters. Flight service providers bill per hectare or flight hour. And input suppliers bundle agronomy with drone-ready prescriptions. Users range from large export orchards and sugar or timber estates to retailer contract growers and co-ops of emerging farmers. Mining is about safety, time, and truth. Drones now cover the full workflow from daily pit surveys to underground cavity inspections and security overwatch, with operators like RocketMine, Rocket DNA, TerraDrone, and Drone Optics flying thousands of sorties each month for majors such as Anglo American, Exoro, Vedanta Zinc, Sibanye Stillwater. The result is fewer risky climbs, faster audit-ready data, and survey cost reductions up to 70%. While BVLOS corridors inside tenements are becoming practical, where detect and avoid is fitted. RocketMine even completed SA's first BVLOS or rail corridor survey in 2022 using Cassia DAA. This is the reliable win. Plan a safe standoff grid, fly at consistent altitude, and lock accuracy with RTK. Process to orthos, clip the data, then compute volumes with the stated error band. The real value is cadence. where weekly or even daily flights give planners numbers and not estimates that reconcile cleanly against belt scales. Typical toolsets include high overlap photogrammetry for stockpiles and task-specific LiDAR payloads for true ground models, with teams like Rocketmine renewing multi-year survey contracts of this predictable delivery. Where it's GPS denied or unsafe, Flyability Ilios and MSN hovermap rigs use SLAM to 3D scan stopes and draw points, while CSIR's mining modernization program has shown drift navigation for rock face mapping and ground support checks. In open pits, the priority is geotechnical risk, so dense, high overlap point clouds track berms, benches, and faces over time, with LiDAR or thermal helping to keep models honest in dust and shadow, so small sleuths, block drains, or tension cracks are caught early without putting any person in danger. UAV and drone solutions report night vision patrols cutting rail cable theft incidents on Transnet lines by about 60%, while Anglo American uses multispectral flights for tailings dam breaches and profiling environmental compliance. Standardizing dam surveillance with fixed flight lines, consistent altitudes, and repeatable overlap let teams compare apples with apples month to month, capturing crest-to-toe conditions, beach widths, freeboards, spillways, and downstream vegetation, with thermal flagging seepages and obliques revealing cracks or rutting, so small anomalies become actionable work orders before they can escalate. Commercial models are now well defined. Survey days typically bill 12 to 25,000 rand, or 180 to 350 per ton for stockpiles, with the value chain splitting into drone as a service providers like Rocketmine, users like Exoro or Anglo American, hardware OEMs like Alti and DJI Enterprise, and analytics platforms like Rocket DNA Cognition. Under the hood, mining fleets mix VTOL fixed wings like Alti Transition and Trinity F90 Plus for wide area mapping, with multi-rotors like DJI M300 and Flyability Ilios for close inspections. They carry RGB, LiDAR, hyperspectral, gas, and thermal payloads, while GNSS, RTTK, or PPK terrain following, and SLAM keep models accurate and underground flights safe. Edge or Cloud AI now turns data around in hours. Think rock DNA cognition, autovolumetrics, angular dust plume detection. So results land quickly in a SAP, Pultram, or Hexagon mine ops. Inside plants, drones take hard jobs on stacks, conveyors, roofs, tanks, and flying closer and safer than any rogue crew can. Security is where drones feel like a true superpower. Licensed operators now fly thousands of autonomous patrols every month across private estates, mines, rail corridors, power lines, wildlife reserves, and metro police using multi-rotors for reconnaissance and tracking. The value shows up in the outcomes. Cable theft incidents dropping dramatically, guards removed from the riskiest positions, and quicker nighttime arrests, and reserves going rhino poaching free for hundreds of days at a time. Plus, hard costs and speed benefits where deliveries fall from hours to under an hour at a fraction of a vehicle's cost. Good patrols are boring by design, and that's the point. We pre-plan geofence corridors along fences and servitudes, add short dwell holds over gates, corners and blind spots, and stagger times so flights aren't predictable. A RGB zoom camera gives positive ID while thermal handles detection, with a spotlight or siren if needed. Every sortie writes its own audit trail. Who looked, when, and at what, which makes investigations faster and keeps contractors and site owners aligned on what was actually seen. When an alarm trips, the playbook is speed and clarity. The drone launches to a pre-authorized hold point. The payload operator zooms in for confirmation, and a live video streams to the control room and supervisor's tablet. We mark last known locations and likely egress routes on the shared map and hand exact coordinates to ground teams. There is no escalation from the air. We simply shorten the loop between alerts and on-scene intelligence. At events and in hotspots, the drone becomes a floating overwatch. By day, we watch ingress, queues, and choke points. By night, we switch to thermal for crowd density and heat stress queues. Flight paths stay outside the crowd volume with safe lateral offsets, and we pre-brief a corded contingency if communications drop. The deliverable is simple: a live map with markers during the operation, and a short post-event note on what went well, where bottlenecks formed, and where to add barriers, lighting or signage next time. In reserves, the priorities are detection and deterrence. We fly quiet routes downwind to reduce acoustic signatures, use thermal to pick up heat signatures, and avoid patterns that tip our hand to repeated offenders. Coordination is crucial between rangers on the ground and the control room. Evidence handling matters too. Timestamp videos, GPS fixes, and a clean chain of custody note, so that prevention remains the primary goal, but prosecution stands up when needed. Short-hop logistics is where regulation has matured the most. Pilot projects by SANBS and other partners have shown how BVLOS, when paired with approved cooperative surveillance, can move blood and samples quickly and safely, cutting turnaround from multiple hours on poor roads to well under an hour in the sky. In disasters, the same toolkit gives incident command a fast, common picture. One aircraft maps the scene, while a second orbits with thermal, spotting embers or survivors, with speakers broadcasting instructions. Corridor approvals now allow operators to fly repetitive BVLOS legs inside predefined airspace blocks once the risk assessment is signed off. We treat each leg like a rehearsed airway: pre-surveyed launch and land boxes, contingency fields, lost link logic, and check-in points, with geofencing, remote ID, and UTM integration layered on top. These corridors turn a once-off waiver into a predictable, schedulable service. Here's how these projects translate operationally. A hub-and-spoke network moves critical payloads between clinics and district hospitals on fixed routes, with aircraft sized for range and pod payload. Point-to-point demos prove the BVLOS link and ground handling, then scale into permanent legs with servicing pathology labs and blood depots. New humanitarian partnership extends the same model to time-sensitive medicines using on-demand drops. Across all three, these operating models is identical: pre-cleared routes, standardized handoffs at each node, and tight SLA from request to received. During the pandemic, we learned that fast enough by road often isn't. BVLOS flights ferrying PCR samples prove that a small aircraft with the right approvals can outrun traffic and terrain to keep labs on schedule. The lesson sticks beyond COVID. For any time-critical medical or emergency management payload, an aircraft is a resilient backstop when road fails on surges. Provincial departments are now writing drones into tender specifications for rapid transport of biopsy slides, antivenom, and emergency medication between regional hospitals. The operating concept is simple: predefined pads at each nodes, a schedule or on-demand leg, and a handoff protocol that keeps clinical staff focused on patients, not airframes. For security teams supporting these flights, the job is to protect the launch and land boxes, maintain clear communications, and keep turnaround time short so the medical clock stays in our favor. Last mile is still pre-commercial, but we're learning where it fits in. Proof of concepts using multi-rotors to drop secure collection points show promise for estates and fenced campuses, and just-in-time spare runs inside big industrial sites are already viable under enclosed site rules. The principle is to complement, not replace road logistics, shaving minutes where minutes matter and avoiding the congestion, security risk, or access constraints that bog down road transport. When floods, fires, or storm cut communities off, drones extend reach immediately. With a small VTOL carrying water purification tablets or shelter kits, we'll bridge the last few kilometers into isolated villages while simultaneously mapping damage and access routes for ground convoys. The goal being to deliver simple, geo-referenced products that tell responders where to go, what to avoid, and where to stage. The goal is safer, faster relief. Recreational flying in South Africa is big and lively. Tens of thousands of hobby-grade multirotors and fixed-wing models are active, with RC clubs from Cape Town to Polokwane, and FPV racing scene that sends national teams abroad. The space rests on two clear tiers, Part 94 of model aircraft and Part 101 for private use drones, with clubs under SAMAA providing insured fields and skills training, while local retailers keep the community stocked. When you are flying purely for sport at an approved SAMAA field, you are under Part 94. The 2025 update also clarified that toy drones and sub 250 gram micros also live under these regulations now. Stepping off a SAMAA field, say to go film the garden route, then Part 101 of private operations apply. You still don't need a license, but you must obey the same altitude, distance, and day VLOS limits. Keep a simple flight log and have the landowner's permission. Night flying or FPV goggles requires an additional trained observer. SAMAA is recognized by the SACAA as an aviation recreation organization and counts roughly 4,400 members across 100 plus affiliated clubs and special interest groups. The backbone of safe insured flying sites and mentoring for new pilots. On the edgy side, FPV brings immersion and dynamicism, but demands discipline. The community spans formal sport and casual creators. Team SA FPV competed in the 2024 FIA Worlds in Hangzhou. Local pilots log times on multi-GP boards and organize meets via Fly FPV SA, while amateur aerial photography is also booming. On the kit side, DJI holds roughly three-quarters of the global consumer market, and South African distributors like Drone World and Action Gear stock the Mini, Air and Mavic lines alongside ND filters, insurance and repair plans. Rules do bite when ignored. SACAA inspectors and SAPS air wing units have grounded illegal flights near airports and stadiums under Regulations 101.04. The takeaway for creators is simple. Plan with altitude, distance and airspace limits. Get permission and keep a tidy log. Prevention is cheaper than confiscation or a court date. South Africa's military UAV story moved from imported capability to local depth. The SAAF fielded the IAI Scouts in the 1980s. Then by 1987, the indigenous Seeker-1 was operational in Angola for real-time ISR and artillery guidance. To the 1990s, the Golden Era arrived with Seeker-2 upgrades, ATE Vulture artillery spotting, and the Kivit mini UAV for special forces, while the Danel Suka became a staple high-speed target drone for air defense training. The typical working areas are small tacticals for backpackable patrol ISR, tactical hybrids for mixed terrain and IR and comms pods, and medium altitude long endurance for border or marine endurance. All built around the same payload logic: see, sense, know, where, and share. The product line evolved from the Seeker 1 to the Seeker 2 to the Seeker 200 to the Seeker 400. And now with the armed sniper configuration appearing on the Seeker 400. Today's fleet reflects that evolution. Seeker 400 delivers 16 hours of endurance, 250 kilometers of range, and supports 100 kilograms of sensors. The sniper variant adds precision strike with up to 4 Mokopa or MP ordnances. The Milkor MA380 steps into the MALE tier with 20 hours of endurance, 2,000 kilometers of range, 1,300 kilograms of IMP-TOW ordnances, and 6 hardpoints, while the MA80 and MA18 covers tactical and mini UAV roles. Industrial momentum is visible in Milkor's 2024 Saudi manufacturing deal. For big systems, the rules get formal. NATO Class 1, 2 and 3 weight bands frame the doctrine, and STANAG 4671 informs airworthiness for larger UAVs. Practically, SA-designed large RPAs face customers who want a foreign type certificate or a military airworthiness release. There is no blanket FAA acceptance of South African RPAs, so resilience becomes part of the offer. Use case anchors remain ISR and artillery spotting from the Seeker lineage and long-endurance maritime patrols, with export traction signaled by the 2021 Seeker 400 deal to the UAE. Procurement rarely matters as forces buy capability alongside training, spares, documentation, and upgrade paths. Currently, the use of UAVs are reshaping the way warfare is carried out. In the Russia-Ukraine war, small FPV drones rule the sky. It all started with FPV drones targeting low-flying helicopters trying to avoid anti-air systems. Their small, fast and disposable nature makes them ideal for kamikaze attacks. Ukraine carried out an extreme BVLOS mission on July 2025, attacking Russian strategic bombers with 117 small FPV drones smuggled into Russia and launched from concealed trucks, while the operators were almost 2,000 kilometers away. This method is currently so effective, both sides have pledged to add a combined 6 million extra UAVs to the fight. South Africa's UAV market grows where three forces line up: regulatory enablement, sector pull from mining, agriculture and security, and capital to scale pilots into programs. Today, the market is service heavy, with select platform exports and strong subsystem talent. The slope to 2030 comes from the routine BVLOS corridor, faster data workflow, and cross-border work into SADC. The landscape mixes a large state player with mid-sized service and tech firms. Denel Dynamic sits near 800 staff with group revenue around 3.7 billion. UDS lists 240 people with around 396 million in sales, noted via the Bidvest report, and 500 million rand purchase price in 2019. Aerobotics shows around 87 people and 227 million in recent sales values, with 486 million in cumulative funding. Alti UAS reports a small team of about 20 and 50 million in turnover. Rocketmine or Rocket DNA and Esplan Automation both sit in around the 50 to 200 band, with revenue bands centered around 40 to 50 million rand. Recurring spend is anchored by PROSA, Transnet and Eskom for rail, pipeline and powerline inspection, and so far the ROI has been strong. One corridor's night thermal patrol cut cable theft to 5% of previous levels and reduced guard count from 200 to 8. Licensed operators now fly thousands of autonomous patrols per month across mines, estates, rails and grid assets, with port pickup drones overwatching where fixed cameras have blind spots. Think of the industry as four stacked layers that move a drone from raw parts to real-world outcomes. Upstream materials and parts that are composites, machining, wiring and batteries, subsystems and integrations with flight controls, avionics, comms, gimbals and autonomy, platforms and MRO, which is airframe assembly, testing, repairs and upgrades, and operators and data, that is ROC, training and analytics. Around the stack sits regulators, test rangers, insurers, financiers and universities, and a healthy ecosystem that keeps multiple players active in each layer of work so it never bottlenecks. For this example, let's see what it would take to build an all-African UAV. Across the build, components resolve into 9 buckets, from primary airframe and propulsion to energy storage, flight control electronics, servos, avionics, navigation, structural hardware, and environmental protection. But the competitive edge is in the solutions: BVLOS toolchains, localized payloads for tailing power lines and wildlife, heat and altitude tuned power modules with field swappable energy, operator enablement, and data pipelines that turn flight data into decisions. Further behind every part is a wide bill of materials: carbon and honeycomb for the airframe, neodymium magnets and silicone steel laminations for the motors, lithium, nickel, cobalt, graphene for the batteries, PCBs and MEMS silicone for electronics, 66:1 7075 aluminium, and A2 stainless for the structure, and epoxies for protection. South Africa is able to supply a vast majority of the required materials. AMT Composites and Aerontech bring carbon cloth, Sasol and NCS supply epoxy, Hulamin and Columbus Steel feed alloys, Palabora copper is drawn by Albede, rare earths tied by Steenkampskraal, lithium inputs span Kalahari Lithium and Bikita, plus local PCB assembly and electrical steel. But unfortunately, some processes simply can't be done yet on the African continent. Pan-based carbon fiber cloth is all imported as no local carbon fiber plant exists yet. So too for aramid honeycomb cores imported via Aerontech. For neodymium permanent magnets, SA can supply the raw oxides, but magnets are still sintered in China. Semiconductor chips are also imported, only PCB assembly happens locally. LED chips are imported and then SMT assembled locally. Finally, titanium ore is local, but smelting happens yet again offshore. Once all the required materials are collected, the design and build phase can begin. Using skilled design and manufacturing engineers, paired with testing and validation methods, this will seamlessly combine the aircraft's flight computers, IMUs, GPS, magnetometers, radios, gimbals, and power systems. South Africa's advantage is the system integration, making multi-vendor parts behave like one aircraft with configuration control, firmware baselines, and tight flight test cards. Representative players span materials and aerostructures like AMT and Aerontech, flight critical subsystems like S-Plane, Hensoldt, Simera, and Rautech, and airframe OEMs like Alti, Denel Dynamics, Milcor, Aviator Labs, and Desert Wolf. As mentioned previously, the South African industry has no shortage of applications for UAVs. Whether it's agriculture, mining, security, or military, the capabilities of the platform are of great use. Platforms such as Alti Ascend has been used in cases such as bushfires, anti-poaching, tracking, and security. On collection, the operator returns the airframe to Alti or an authorized MRO. A George Disassembly Station issues a waste manifest and ships segregated components under SAWIS codes. For e-waste, it is 261, plastic 222, composites 145, and non-ferrous 141. A typical circular yield is 95% for aluminium, 90% for copper, 60% for carbon staple, 92% for lithium ion metals, and 98% for titanium, and finally 80% for plastics. What comes from the earth will return to the earth. Recycling has of lately become of great importance in the circular flow of materials around core parts. Carbon epoxy skins go to Aerontech using a CSIR pilot for pyrolysis that returns a short carbon staple. Aluminium mounts are deriveted and recycled via Hulamin. Stainless steel and titanium head to Columbus or Novamet. VLDC motors are shredded to separate copper and rare earth metals. Lithium-ion packs go to Liber SA for discharge, dismantle, and cathode metal recovery. PCBs are smelted at Universal Recycling. Wiring looms are stripped at Albedare Green Metals. Plastics are granulated at MyPlas. And hazardous residues are treated as per the Waste Act. South Africa plugs into the global UAV economy in both directions. On the buy side, we import critical components, host foreign OEMs, and co-develop through joint research and development and licensing, while aligning to international standards. On the other side, we export raw material, ship South African-made airframes and payloads, deliver cross-border drone-as-a-services, and provide certification using testing. Partnerships that work well follow three patterns: prime and a specialist, one leads with a niche payload and comms partner, ROC-led consortiums, operators led with platform and data partners, and OEMs plus channels, resellers bundle training, and MROs. Engineers work across the whole UAV lifecycle. In research and concepts, teams like Denel Batelier and CSIR Limu turn missions into requirements and system architectures. They blend aerospace, materials, embedded systems, control, and software. Design and manufacturing converts those designs into airframes and systems. Think aerostructures, power, harnessing, and DFX, so builds are consistent and repairable. Alti's fixed-wing platforms are a good example. Testing and validation happens at ranges like Ovenberg and field trials. It needs flight test skills, instrumentation, data capture, and systems thinking to provide safety, reliability, and compliance. Operations and deployment support mining, farming, and security fleets. The core skills are remote sensing, telemetry, avionics integration, and day-to-day fleet management with clean data delivery. Regulation and policy at SEAA rely on safety engineering, human factors, and airworthiness know-how. Training and education in university labs feed flight systems, mechatronics, robotics, and pilot technician pipelines. Subsystem supply spans electronics, AI, ML, sensors, energy systems, and local PCB assembly. Defense roles cover aerospace design, control systems, and electronic warfare on platforms like Seeker and Milcor MA380. Above all, UAVs are a team sport. Aerostructures, avionics, RF, GIS, data, compliance, and project operations must click. Many people start as technicians or pilot and grow into systems QA. If you can write and run a test plan, you can add value on day one. Commercial UAV operations rest on three compliance pillars. Pilots obtain an RPL at an approved ATO. They maintain currency through recency and periodic proficiency checks, keep a complete logbook, and hold radio competence when required. Organizations operate under an ROC with documented operations manuals, safety management systems or SMS, maintenance program, and evidence of training. Privileges are defined in operation specifications like nighttime flight, EVLOS, BVLOS, and spraying. And named post holders oversee compliance. Records, audits, and configurations controls must be demonstrated and traceable at all times. Maintenance follows the OEM program and, where applicable, a UAS maintenance technician authorization. Good practice includes parts and battery traceability, airworthy directives, and release to service entities aligned with the ROC's maintenance control system. The talent pipeline runs from university labs into ATO and operators. Outside South Africa, the RPL is not automatically recognized. Most jurisdictions require validation or conversion. Example, the EU or UK conversion, or the US FAA Part 107. South African licenses and airworthiness letters are credible but not automatically transferable. Within Southern Africa and UN projects, validation is usually straightforward. In the EU, you typically convert your local air law and short skills test, and in the USA, you must pass the FAA Part 107. But there's no foreign recognition of RPL. SCAA can validate a foreign RPL into South Africa under SA CATS 101 and will endorse foreign Class 3 with medicals. EASA or FAA generally reissues locally. For small UAS going abroad, there is no mutual recognition of a RLA importing states using their own ops authorization or required ASTM compliance files. For large UAVs, customers expect a foreign type certificate or military airworthiness release. There is no blanket FAA or EASA acceptance of the South African RPAS designed approvals. This section deals with intrinsic risks of operating UAVs and the ethics that keep programs trusted. First is safety and airspace risk. Mid-air or ground impact, lost link and battery thermal runaway. We mitigate these disciplines with pre-flight risk assessment, conservative weather minima, robust link management, detect and avoid where needed, geofencing, redundancy, and rigorous maintenance and battery stewardship. Next is privacy and data. UAV can drift into surveillance creep. Keep capture proportionate to the purpose, obtain consent where appropriate, avoid lingering over private spaces, and encrypt, retain, and delete data to a written schedule. Publish what you collect and why so. Communities won't be surprised then. Security and misuse risks cover dual-use weaponization, critical infrastructure targeting, smuggling, and signal interference. Apply client vetting and export controls to harden links with encryption and interference monitoring. Lock down access to aircraft and payloads, and coordinate with CUAS measures. With autonomy and AI, perception errors and bias can mislabel people or hazards. Keep a defined human in on the loop, validate models on local data, log decisions for audit, and set clear override rules for automation failsafes. Environmental and resource ethics include noise and wildlife disturbance, e-waste and lithium-ion fire handling. Fly quiet profiles and suitable time windows, maintain wildlife standoffs, design for repair and reuse, and send end-of-life batteries and electronics to certified recyclers with documented chain of custody. Finally, social and equality risks, job displacement concerns, unequal access to benefits, and community acceptance. South Africa's 2025 to 2035 UAV path is about aligning with global models and scaling routine operations. Keep Part 101 anchored to ICAO structure while referencing NATO or STANAG for larger military systems. Formalize risk-based oversight via JARU SORA or open, specific and certified tiers. Use EU C0 to C6 categories as a yardstick for imports and local OEMs. A net regional portability through SADC with practical parallels to the American FAA. Regulators are signaling remote ID, UTM integration, corridor-style BVLOS, and licensed drone ports, so flights become predictable, schedulable services. With this full tour of South Africa's UAV ecosystem, how it evolved, how it's regulated, and what the technology stack looks like, from airframes to autopilots to links, payloads, and power. We walked the major industries: agriculture, mining, security, logistics, recreation, and defense. Then looked at market dynamics, the value chain from materials to operators and data, the skills pipeline that keeps fleets safe with audit-ready data, the risks and ethics, guide rails that protect people and privacy, and a 2035 outlook built on risk-based approvals, remote ID, UTM, corridor BVLOS, and pragmatic hybrid VTOL operations. My final take on the South African industry. Our strengths are subsystem integrations, mission delivery in mining, agriculture, and security, and a growing bench of OEMs and subsystem firms. Constraints remain in certified BVLOS toolchains, local component depth, and scale capital. But the policy direction is favorable and the talent is there. Globally, we connect in both directions, buying components, standards, and know-how, and selling platforms, payloads, cross-border DAAS, and certified testing services. The partnership models that work are Prime plus specialists, ROC-led consortia, and OEM plus channels, all aligned with ICAO, JARU's, FAA, and EASA practices. The playbook going forward is simple. Pick one repeatable mission, standardize kit and SOPs, keep data pipelines that deliver decisions, not files, invest in people and safety culture, and engage communities on privacy from the start. Do that consistently, and South Africa not only scales at home, it becomes the regional hub that global partners trust.